Hello there, my name is Jackson, and today we're going to be creating a simple behavior tree AI. This is going to be a beginner's tutorial. So straight away, I'll just show you how to make a project, I guess. We'll keep this really simple. Open your Epic Games launcher, click launch of your engine, whichever engine you've got installed. So that's up in the top right. I'm in 4.27 today. Click games, new, third person, next, starter content enabled, and then all the other settings there are fine. And then I'm going to call this tutorials 2023, and I'm going to turn this into a tutorial series, I think, where we cover a lot of the basic stuff in Unreal Engine and actually explain it properly, because in a lot of my previous videos I've sort of just blitzed through things and I never really explained a whole lot of what was going on. So that's what we're going to do a little bit in this series. We're going to slow it right down. So in my content browser, I'm going to right click and create a new folder and just call this tutorials, because this is where I'm going to put all the tutorial content. Now we're going to be creating a simple AI from scratch today. AI meaning artificial intelligence, which can move around randomly, and we're going to use behavior trees to do that, because behavior trees are a much more powerful way to do AI than just inside of a blueprint event graph. And that'll become obvious why as we go on. So to create a new character, we're going to go new blueprint class and type character and just call this BP underscore my simple character. I like to put my in front of things to differentiate it between something else that might be in the editor that I didn't make, so I know everything with my in front is mine. Now straight away we can drag him in, and you can't see anything there because he doesn't actually have a body, so let's just give him a body. This is what he looks like right now. So if we go add component and go static mesh and just call that SM, and then just add a cube, our dude can be a cube today. Okay, that's rad. Okay, so that's our AI. He's there. Okay, that's his body. He exists. He's in a world, right? But at the moment, he's just a body, and he doesn't have a. The way I like to think of AI is like, AI is sort of the brain that you give to a character. This is just another character here. Now, if I hit play and jump in, this character has been possessed by my controller, my player controller. But this dude over here, this hasn't been possessed by anything. He's got no brain. He can't do shit. And likewise, if I just hit simulate like this, we've got two characters, the one that we just created and this other character that started in the scene, and they're both bodies, but neither of them have got any brains, and they don't actually know how to do anything. So that's the first sort of concept, I guess, is this idea of possession. It's like you can have a character that exists in your game, but he's just a body unless you give him a brain. So the next thing that we need to do, if we're going to be creating what we call AI, which is artificial intelligence or shit moving around like by itself as if it had its own free will and like whatever, we need to go into our content browser, new blueprint class, and we need to make a brain for the AI. So if you go to all classes down here and then type in AI controller, you type in an AI controller, you select AI controller, and I'm just going to call it AIC underscore, we'll call it simple brain, because it's a simple brain for an AI. So down in the content browser we have the body and we have the brain. Now we need to tell the body to use the brain. So if we go into the simple character, click on the top there, my simple character, and then over on the right, AI controller class. It has been given a brain, AI controller, but that's just the default one. We're going to tell it to use our brain that we've given it. Okay. And auto possess AI placed in world or spawned. I always like that to be or spawned. So whenever you spawn one of these in the game, sometimes your AI doesn't do anything because it doesn't actually have an AI controller. So I always like to have this set there. Okay, so now he has a brain. Now we have a body, we have a brain. Now we need, what would you call it, like neural networks and like subroutines and things that it can do. Like if you think about a person and the behaviors that a person engages in, one way to conceptualize their behavior is it's sort of like a script that's running inside their brain which is controlling their body. That's one way to think about it. Or you can think of it as like a script which is executing itself through a person's soul, which is a player controller, which is then animating their body. That's another way to think about it. It's the same with AI. The AI has a brain now. It has a body which can move given inputs from the brain, but the brain doesn't have any information to actually execute. You need to feed information into the brain and invent decision making and routines and movements and actions to tell the brain how to use the body. So that's the next thing that we need to do. And the way that we do that, you can do it in the event graph, but anything in this event graph is not reusable across different characters. It'll be restricted to this event graph or anything that we create a child from this event graph. So if you want to be able to use different behaviors for different brains in different bodies, you can abstract all of that out into what's called a behavior tree and in behavior tree tasks. So that's what we're going to do now. And this is really, really simple. There's so many complicated tutorials on this shit, and it's like everybody sort of misses the point. Behavior trees are literally just, it's a mechanism for decision making, and they don't have to be complicated at all. So if you got artificial intelligence and then type in behavior tree and just call this BT, and now let's give it a specific name, knowing that this is not tied to a character. So I'm not going to call this my simple character, BT underscore my simple character, because the simple character is a body, and I'm not going to call it BT underscore simple brain because it's not a brain. What this is a set of instructions and a particular pattern of behavior, which is then fed through a brain and then executed in a character. So if you think about it in terms of a behavior, what kind of behavior is this? Today we're going to call it random roaming. Okay. Hopefully I'm not going too fast. If this is the first time you've watched something like this, a lot of what I'm saying will be too quick and you won't be able to digest it, which is okay. So what I recommend to do if you're watching these videos and you're new to Unreal Engine and you're new to game development and a lot of the concepts that I'm talking about here, is to watch these videos from start to finish first without trying to build anything that I've been making. Maybe even watch them twice, and then once you feel like you understand everything that I'm saying, then what you do is you go back to the start, you watch it, you see what I'm doing, you pause it, you recreate what I'm doing, you start it again, pause it, create what I'm doing, and skip back and forwards as you need. That's how I recommend that you do it if you're a beginner to this stuff. If you're advanced, then I've got plenty more advanced tutorials on my channel where I just blitz through shit like a fucking psychopath. A psychopath on 24 Red Bulls and some LSD. But today we're gonna just be just chilling and going slow and vibing, alright? This is sort of hangout, in-depth learning time. So we're going to have a random roaming behavior. Now, if we open that up, there's not a whole lot in here. Because, well, there's not meant to be, because it's like basically a blank piece of information. We're going to have a selector node, which selects stuff. We're going to have a wait node, which waits. Really simple stuff so far. So basically, if I ran this now, I mean, this is already a behavior tree, technically. Like, literally. So why don't we just run that? We could literally run this now, and I can show you it running. So, to get this guy to run a behavior tree, we could, inside of the simple character, go begin player, run behavior tree, blah, blah, blah. But then you'd have to add this for every single character. Like, if you wanted to have a separate character, you know, which could be BP, my second simple character, and say he was like a freaking triangle or something, like if he was completely different, you'd have to tell this to run a behavior tree as well. And then it's like you're copying code from character to character, and you don't need to do that. Whenever you find yourself copying lots of code, there's probably a better way to do what you're doing, because it's a waste of time. So you don't want to be using the same code in different places. You want to be using or copying the same code to different places. I mean, you want to be using code in different places, but all drawing from the one place. And so the way that I like to do that, I mean, there's a million ways that you can do this, but the way that I do it is I create a blueprint class, I create an actor component, and call this AC underscore run behavior, or something like that. An actor component is literally what it says it is. It's a component which can be added to an actor. So if I go into my BP simple character and go AC, what did I call it? Simple or run behavior or something. AC run behavior, and then just add that in. We can get this to do all the scripting just by itself. So inside of AC run behavior, on begin play, what we're going to do is we're going to get the owner of this component, which is my simple character. We're going to get AI controller, okay, and then we're going to say run behavior tree. And now we can promote this to a variable by dragging off of here and just call this BT, I guess. And we'll make that, we'll tick the I on that, so that's a public variable and that can be edited. And then basically any actor that has this component will just run a behavior tree straight away off the bat. So if I put in as the default for the BT our random roaming behavior tree, this is done. We can close that component, and now this guy here at begin play is going to run that behavior tree. Now the other guy, we can get him to run it as well, and we don't need to copy code. All we need to do is just add in this, and they're both going to run the same behavior tree. I prefer to do it this way rather than copying code, in case you want to add more complex logic to which behavior tree they should be running. So now if let's delete our second guy, but if I hit play, now it looks exactly the same as before, but if I open up the behavior tree, you can see there is an option up here somewhere. You can select the AI from the drop down, AIC simple brain C underscore 0. This is just saying that it's running, this behavior tree is running on this brain, okay? And this brain is inside of this guy here, if you want to think about it like that. So he's successfully running a behavior tree already. Cool, right? Like really, really, really simple. So now if you wanted to get him to do something more complicated, what we do is we use these things up here, which is called a task. So maybe what we can do, we can use a sequence node, and the reason that I'm adding this over to the left is because this is how the decision making works in behavior trees. So this is a new concept that I'm about to teach right now. Execution starts at the root, and you can think of it like water, which chooses which way it wants to flow down. And the whole system of behavior trees is designed to choose which behavior should be running given a set of circumstances or input. It's like, if you think of the way that your brain runs its behavior tree, it's like if you're about to cross a road and you use your perception and see that there's a car coming and you don't want to die, you will block off the behavior that says cross the road, and you'll probably just wait until the car's done crossing the road, and then you'll the car's done passing, and then you'll cross the road. So it's the same thing with behavior trees. You can have different gates on these. So for example, if I had a blackboard on here, this checks a condition to see, oh well, is there a car coming? If there is, then this whole branch is going to fail. We're not going to cross the road. Instead, we're going to do this branch over here. And the way that this works, the way that the behavior tree selects which node to run, is it always checks from left to right. So if we go down to this selector node, the first one that it'll try to select is on the left here. And then if this fails, it'll go to the next one, check that, next one, check that, next one, and it'll keep going until it succeeds. So what you always want is a wait over here on the right, because if everything else fails, then you just end up waiting for a second or 5 seconds or whatever. Okay, simple enough. So let's see if we can build our first behavior, which could literally just be oops, I just clicked new task, which I didn't really mean to, but hey, let's just roll with that. straight away what I like to do is go Control Shift S to save it because it had a little asterisk, and then I go Control B and it browses to where that task was created. So I'm going to call this BTT, hitting F2 to rename it. BTT get random location near actor. This is a task that a brain can run. Okay, so you want to keep that in mind when you're naming things. So let's just, before I add code to anything, let's look at how this might look. So this node up here was a select node, which selects the first node it can, starting from the left and then moving progressively to the right. A sequence node runs all of its nodes in sequence, and you can hover over these if you want to read them. So if we think about what we want to happen, the first thing that we want to do is, if we're going to be building a random roaming behavior, which is what we're going to be doing, by the way, spoiler alert, I don't know if I mentioned that. The first thing that we'll do is we'll get a random location near actor, and that actor is going to be ourselves, because we're just going to be roaming around our immediate location, like sort of simple stuff. We'll do more complicated ones in future videos perhaps. Get a random location, move to location, which already comes inside of the editor, that's a default one, and then maybe what we'll do is we'll wait there for 2 seconds plus or minus 1 second. Okay, and then once that's finished, this whole thing has then succeeded. This whole sequence has then succeeded, which means this selector node has then succeeded, which means it's done, the root's done, and then the root will fire again, and it'll do the same thing again. If this were to fail, the select node would then cut that branch, and it would go to the next thing on the right, which is the wait, and after it waits for 1 second, that task succeeds, this succeeds, the root succeeds, and then the root fires again and tries again. So it'll try from the left and then go again to the right. So that's how behavior trees work. Now, this is not going to roam at the moment because it doesn't actually have any logic inside of this task, which is getting a random location near actor. So if we double click that, we can open that up. Now, first thing, I type in recx AI, event receive execute AI, which just means this task has been fired / activated / whatever. The controlled pawn is our character, which is possessed by the AI controller. That's this. And then the owner controller is the AI controller, simple brain. Okay. If we want to get a random location near the control pawn, we get a reference to the control pawn, and we could say get location, get actor location, and then we could get random point, get random reachable point in radius. See, there's already a node that does it. So the origin will be where we are, and the radius can be a public variable, so we'll drag that off and promote and just call that radius, literally. Nice and simple, and then make that public by clicking the I so we can edit it. Now, once we've got that, we can finish execute. So the thing about these tasks is that you need to actually mark them as a success, otherwise you need to mark them as a success inside of the task itself, otherwise the behavior tree has no way to tell if this actually succeeded or if it failed. Because sometimes, for example, if you can't find a location, you might want this to fail because you don't want to try and then continue in the sequence to move to a location that it couldn't find, right? So if this fails, the whole sequence will fail, and then the selector will default to the next task on the right. So that's something to keep in mind when you're doing these tasks, is you need to remember to finish execute after you've done your script, and then have different conditions for success versus fail, because then that can control how the behavior tree works its magic. So in our case, as soon as you get the location, I mean, we're just going to assume that it's always going to succeed, because it probably will. I think it will. So then what you do is you just go finish execute success. Now, the value's here, but we can't do anything with it from inside of this. It's like, okay, well, we've got the random location, but like, how do you get that from here inside of this task into this move to node to tell the brain or the the software on the brain to move to that actual location. And the way that you do that is with a thing called a blackboard. So let me create a blackboard, and then I'll explain what that does. So if you right click in your content browser and create a blackboard, and then call this bb underscore, this could be called basic blackboard. BB for blackboard, basic blackboard. And what this is, well, if you think about what a blackboard is, what do you do with a blackboard? It's like you write shit on it, and then it like stays on there in chalk or whatever. And I suppose you can rub stuff out and edit it and like whatever. It's basically a storage unit for information. So a blackboard, when it comes for AI, it's a thing that is always paired to a behavior tree, which allows the behavior tree to write information onto a blackboard like you will with a piece of chalk, and then use that information and remember that information to change the way that it makes decisions. So in order to tell this AI where to move to, we need to record the move to location from this task onto a blackboard, and then draw that information from the blackboard in this move to node. That's how this works. So, but before we can even do that, we need to pair the behavior tree to the blackboard, which I don't remember how to do. So let me see if I can figure that out. If we go to our BT random roaming, you can see there's if you just click on the event graph, left click on the event graph, you get AI, behavior tree, blackboard asset, and then you click that. Now it's got a blackboard. Okay, boom. And you can see it just appeared up there because this root is reading this blackboard data. So now if we go over to the blackboard, you can toggle between the two just like this. So you can see here's the behavior tree, here's where it's storing its information, which means I can close this blackboard asset now, and I won't need to open that blackboard asset again because you can just open it from here. So if we open up our blackboard, we need to add a thing called a key, which is a different variable type where you can store information that can then be used inside of the behavior tree. So if we click blackboard, new key, we need a vector because we're storing a location. So let's just call this move to. Okay, it's a vector and it's just called move to. And the self actor will just, that's a default one, and that'll always just be a reference to whichever actor owns the blackboard. Okay, so we have a move to vector on the blackboard. So how do we write to the blackboard? Well, let's go into our get random location, and off of here, the random location, we're going to say set blackboard value as vector, and then just put that in the execution chain. Now, which blackboard value are we setting? Well, we're going to create that. We're going to make that a variable. And it defaults to the name key, but what I like to do is I call it bbki underscore, bbko, I'll explain in a moment, move to location, or maybe I'll just call it location output. And the reason I call it location output is because the name of this task is get random location near actor. So if you read the name location output, automatically you're going to make the connection, okay, well that's the location that's outputted from this thing. Okay, now bbko means blackboard key output, bbki means blackboard key input. I like to differentiate between those two because sometimes, let me just hit this eyeball here so it's editable. Sometimes if you have a bunch of different keys, you can view all those defaults by clicking on your task up here. You might have like 5 different keys, and if your naming isn't clear, you won't be sure which ones are meant to be variables that you're putting in and which ones are meant to be variables that you're getting out and then using in another part of the graph. So I use this convention bbko for out, bbki for in, and then just a descriptive name afterwards. So now if you look at this, event receive execute, we get a random location near our radius, which we're just going to set as a default to 500. 500's a good, no, let's go bigger. 1,000. Let's move real far. 1,500. And then we're updating our Blackboard value as a vector, right? We're feeding it a vector, and our Blackboard key is the location output, and then we're marking it as a success, okay? So this is done. We can close that down now. But now what we need to do is we need to set this up. So the radius is fine because we're going to be moving in a radius of 1,500, but we can make that bigger, we can make that smaller. It's completely editable depending on what type of behavior you want it to run. Now, the location output, this is where it's writing to the Blackboard because I've named it BBKO. If this BBKO bit was covered and it just said location output, or even just like location or something, you wouldn't be clear on what this did, and you wouldn't be sure if it was something you were meant to set or something you were meant to get. But anyway, so BBKO, location output, we're going to output that to the move to location on our Blackboard, and then we're going to use in our move to node down here in Blackboard key our move to location. So in sequence, what's happening from left to right, we're getting a random location near ourselves, we're moving to that location, and then we're waiting for that amount of time. This all marks as a success, the selector marks as a success, the route continues, and then it goes again. So it'll go back through, back to the sequence, get a new location, move to, wait. Get a new location, move to, wait, and it'll just repeat and repeat and repeat and repeat and repeat. Okay, simple Blackboard behavior tree. Shall we give it a run and see if it actually works or if I'm full of shit? Hit simulate. Do we have a nav mesh in here? It doesn't look like we have a nav mesh. Is that something that I forgot to do? Okay, so before your AI can move in here, you need to go place actors and then type in nav mesh bounds volume. Drop that in. I'm going to center it to 000, just down here in the bottom right, and then I'm going to make that a little bit higher so you can see it, and then spread that across the whole thing. And you just press the P key to toggle the nav on and off so you can see it. But now, what's going on here? So, okay, you can see that he doesn't have navigation around his body because the cube is blocking the navigation. So if you go to the static mesh and then scroll down to collision presets, set that to character mesh, because it's a character mesh even though it's a cube. And now that'll stop blocking the navigation, so you can see he's got green under him again. So now I'll press P again to hide that and hit play. We've got our boy moving around now, or girl, or whatever the hell he is. It is this horrible thing that we've created. We've given a cube sentience. It's just going to roam around in this cube world for the rest of its existence. You don't know what these things get up to in here when you turn the computer off. You don't want to know, trust me, it's no good. But to be honest, maybe he's happy here. I mean, he's surrounded by cubes. Like, there's cubes on the stairs, there's cubes, there's walls. Everything's made out of edges, you know. And this guy has how many edges? 8 edges, 16 edges. I don't know, but he's got some edges. And you can see over here on the right now. So this is the cool thing about behavior trees, is you can literally visualize. Oh, I can't move that while it's running. But I was going to drag that across so you could see it a little better. But on the left, you can see him moving around, and on the right, you can see what he's thinking. That's literally what he's thinking. The behavior tree is like the thought process of an AI. So you can see he's running the sequence node. He's waiting. He just got his location instantly. He moved to it. Now he's waiting. Now he's moving. Now he's waiting. All right. So simple. So that's how you think of it. This thing on the right is his brain. This is his thought process, how he makes his decisions, and then you can see what that looks like on the left of the screen over here. So I think I might leave that there. This is a basic introduction to behavior trees. I do have more advanced behavior tree content on my channel. I have an AI Made Easy series, which I go into quite advanced stuff, to be honest. This is a very beginner tutorial to just get you started with behavior trees and see that they're not something to be afraid of. Like, they're really, really simple, and they're incredibly powerful. Like, once you get the hang of what you're doing, and you start to build up a lot of these tasks, if you've designed these properly, you can migrate these from project to project to project and basically build up your own library of different AI behaviors which you can reuse to every AI that you ever create from that point onwards. It's like once you design a task, you just copy it to a new project and you can reuse it. So you end up being able to do really good complex behavior trees. And let me just show you one more thing, just for the sake of like demonstrating the power of this. This is our random roaming behavior tree. Let's create a new behavior tree. So AI bt underscore move to random point near self. That's basically the behavior that he's doing, right? This whole thing, he's basically moving to a random point near self and then he's waiting. So if I wanted, I could cut that, open up that new behavior tree that I just created, copy that in, boom, just like that, because that's what it's doing. Now in here I can say run behavior, and then in behavior asset, move to random point near self, just like that. And then if that fails, then we wait. So this is how you collapse your behavior tree graphs. So basically you could have a big ass behavior tree of itself inside of here, which could be a very specific type of like combat, for example, or an evasive behavior, or a searching behavior. And then you could have like 10 different ones of these, and then have like a meta decision making process between which behavior tree to use. Just so you know, like you can collapse these and just make the most complicated shit inside just a single node like that, and then have a monstrosity of behavior tree selecting between different behaviors of their own. So the sky's really the limit, right, with the kind of shit that you can do with this. So just to demonstrate that running, you can see he's just running that one behavior and it'll always succeed, because I mean there's no point where he's ever gonna fail it. When he might fail it is if you introduced a condition where he would only roam if the player was X distanced away or whatever. But you can look into my AI Made Easy series if you want to learn a little bit more about that sort of stuff. But let me know if this is helpful, like slowing this down like this, and if you would like more tutorials like this, because if you do, I will, but you need to let me know, because otherwise I don't know if anybody's watching them. I feel like a lot of the so-called views on YouTube are literally just like bots and like not even real people, and so it's hard for me as a creator sometimes to know or to gauge if there's actually interest in something, or if I'm just sinking all this time into videos that just go out into the fucking void and don't even reach anybody. They're just reaching fake computers. So yeah, if you would like to see more beginner AI tutorials like this, or beginner tutorials of Unreal Engine at all, let me know in the comments right now. Alright, I hope that was helpful, and if you have any questions, drop them below as well. Alright, bye bye, until next time.